I am part of the Chicago Corey contingent of the Ruby community. As they said, I've been working in startups for a while, and I really care a lot about giving back to the community, and I'm very honored to have the opportunity to share with you guys what I have learned about architecture as it applies to Rails applications. So I am going to talk to you about the A word, software architecture, something that we don't really talk about very much anymore. What I mean by architecture, this is a formal definition, but what I mean by it is something different from what a lot of people mean by it, and I think we all have different ideas of what architecture really means. I think of it as something that's both viable, it's finding a balance between viability in the short term and maintainability in the long term. It's a compromise, a series of compromises. We want to make sure that we're delivering a solution that actually works without spending too much time thinking about the design of it. But if we spend too little time designing it, we're essentially paying our mortgage with a credit card, and we're accumulating debt that's going to come back and hurt us later. So architecture is some science. There's definitely a methodology to it, but I like to think that a lot of it comes down to technical aesthetics, a sense of beauty and symmetry that you develop over time. This is Foucault's pendulum. Architecture over time, especially in the open source world, in the world that we move in, swings from clarity to agility, back and forth and back and forth. Less and more design goes into what we do. It's really a conflict between big upfront design, the architecture astronaut, and the cowboy coder. And James Gray gave a talk at Ruby Midwest in which he said that every developer falls on a spectrum between one of these two extremes. So I want to talk a minute about big upfront design. It's part of our history, and we should acknowledge it as such. So it's much maligned, but the decision to do big upfront design, it wasn't stupid people doing stupid things. There were actually really good reasons for doing big upfront design. We had the luxury, and I've been doing this for a while, so I've been in this world. We had the luxury of long-term product roadmaps. Things weren't moving quite at the pace that they are today. We had stable platforms. We had standards that were very formal. So design led to high predictability, understandability, maintainability, and really a guided evolution of technology along a pre-plotted path. But of course, we all know it had some disadvantages as well. When you failed really big and you failed really late. Your solutions were untested until they were actually delivered, and you had to cross your fingers and hope that you did everything absolutely right, because change was expensive and failure was expensive. So the pendulum has swung in the opposite direction in modern times, and we have what I call ad hoc architecture. We have guiding principles that sort of determine what we build. These are all of the promises of modern frameworks. A lot of the architectural decisions are already made for us. And in theory, we can spend all of our time focusing on what's called business logic, a term that I've always had issues with. So we have the best of intentions, we do these things, and what happens is our design emerges slowly over time. Great intentions, we hope that everything sort of lines up in the end. It doesn't always happen that way, unless you happen to be building a monorail. So how does this happen? Instead of focusing on business logic like we could or should, we fight against conventions because our case is a special case. So the 5 controller verbs, for example, they last for 10 minutes, and then you introduce this search method to your controller, and that's the beginning of the end. You end up with logic leaking into your controllers, and scaffolding and generated code is part of the problem here. When you generate a controller in Rails, you get conditional code. Conditional code begets conditional code. Just like real life, relationships are really easy to start and really hard to maintain. When your object graph gets to be about 3 miles wide and replete with callbacks, good luck with your test suite. Where do we put non-persistent models? I don't know. What do you think? Junk drawer. And we end up with a gem file that's a mile long. How many of you actually know what the Ruby Racer does? And what happens if it goes away? It's always there. We have gems that we don't know what they're there for. We don't know who introduced them, and we're afraid to take them out. Caleb Kornman once said that the user model is the Katamari Damacy of Rails. It picks up methods and attributes as it rolls through your application. That never happens to anyone here, right? So how can you tell if you have a design, an architecture that is degraded? Change becomes hard because every change has a ripple effect on your application. You can't always predict what's going to happen. And when you do make a change, unexpected parts of your system break. You find that you can't pick up your code and move it to other applications, let alone to other parts of your application, because it's really entangled. And you have increased difficulty in adding new features. The rate at which you can add features gets slower and slower over time. So change gets harder over time. This is a very scientific graph. Time is the x-axis, and the difficulty of change is the y-axis. And there are no numbers here because I'm not a numbers person. But at the beginning, change is relatively easy. After a while, you get to the point where if you have an intern or someone who just came out of dev boot camp, you're going to let them make the change. Then you hear about a feature that's coming up and you decide it's time for a vacation or you're really not feeling very well. And finally, your reaction is to kill it with fire. So how did we get here? We got here by painting by the numbers, believing what we read on Stack Overflow, relying on the behavior of things that we don't fully understand. We've also had dozens of hands on the code. It might have been written by consultants who were building an MVP, and now you have to live with decisions that were made based on short-term circumstances. Classes attract new methods the same way that black clothes attract cat hair. As a test suite grows, your TDD practice goes away, because if you have to wait minutes for your test suite to run, you are not doing TDD anymore. Finally, physics teaches us that systems evolve toward a state of maximum entropy. So even if you're doing everything right, eventually your design will degrade, and it happens one line of code at a time. Uncle Bob said that most software eventually degrades to the point where someone will declare the design to be unsound. And I think there's a lot of truth in that. So let's take a step back and decide what's important to us as developers and as people who are participating in an ad hoc architecture. There are a lot of new developers that are entering our field, and we want to find a way to respect their ideas and their enthusiasm and temper it with our experience of what works and what's maintainable. We want to apply solid design principles and create good solutions that people want to use. Good code, we find, lends itself to use cases that were not necessarily what we had in mind at the beginning. So if we think of a values-based approach, we might implement these things and hope that we arrive at a better architecture than we do if we simply ignore our values. So let's apply these values to our architecture. There's been some exploration of alternative architectures lately that I don't think get enough attention. And one of the things that I find really interesting is the concept of hexagonal design. So we're all familiar with MVC, and we hold MVC up as an ideal, but it's very, very easy to violate its principles. In practice, layered architectures break down. I've seen sessions passed down to models, and nothing is going to stop you from doing that, and no one's going to yell at you if you do that if they don't see it. So it's really, really easy to violate our layered architecture. So what if we think instead of domain objects as pure Ruby classes in a cluster? And this cluster has edges that we're exposing to the world, exposing to consumers. And what if we drop in consumers to these edges as we want and swap them out as we want? If we're doing it in pure Ruby, as you'll see, it gets much, much easier. We can think of our testing framework as one of the consumers of our logic. Our persistence layer, despite what Active Record would have us do, persistence is a service, not a class hierarchy. Persistence is a service. HTTP is a service. It's an interface between our application and most of our users or other applications. The command line, we use rake, we use cron jobs. That's a consumer of our app and our logic. You might have a messaging system in place, and you might have you should have a monitoring system in place. So if you build those sort of consumers into your application, you're locked in to a specific implementation. You're locked into what is good and bad about that specific implementation, and you'll find it very hard to swap things out. So if you take the more disciplined approach and keep your domain objects pure, you can use different services at the different edges. You might start out with a Sinatra app. Every sufficiently advanced Sinatra app becomes Rails. So over time, you might drop Rails in instead. You might say, I don't like Postgres anymore, I'm going to go to Mongo. This gives you the flexibility to change your mind about fundamental components of your architecture. Your users include your customers, your internal staff, tests, scripts, cron jobs, other applications. You want to design for all of those equally. You want to give every class its own distinct API. We don't have the concept of formal interfaces in Ruby, but we can think about the API that our objects expose to the world and try to be disciplined about the methods that we're exposing and how they're called, and make sure that we're enabling correct usage. Rails is great, but we are at a Ruby conference. We are Rubyists first and foremost. Let's remember that and write our applications in Ruby and know the difference. This will let us achieve framework independence. Ruby existed before Rails, and it's my opinion that Ruby will exist after we're done with Rails. So I want to talk a bit about using APIs and messages. That's probably why you're here. There's this great quote by Doug McElroy, one of the fathers of Unix, that you should write programs to handle text streams because that's a universal interface. I would amend this a little bit and say that you should write your programs to handle HTTP because that is a nearly universal interface. So I talk about ecosystems of small applications. You notice that I have not used the three-letter acronym to describe services and APIs, and I don't intend to. I think of an ecosystem, and I use that term very deliberately. A healthy ecosystem consists of symbiotic relationships between organisms that have the resources they need to live and to grow and to be healthy. That's what our applications should look like. That's what our architecture should look like. So we need to decide, in order to implement this, we need to sort of segregate areas of functionality. Decide which applications we need access to which models. Do not try to share, by the way, models between applications using Git submodules or engines or anything like that. That is the road to the sixth circle of hell. And as I said before, I'm going to bang this drum a little bit more. Persistence is a service. We bind our applications together using APIs and messages. It's about sending and receiving messages. I'm going to come back to that. When you're sending messages, when you're using APIs to pull data between systems, think about your caching strategy. Think about how fresh your data actually needs to be. Is it okay if it's 5 seconds old? Is it okay if it's a day old? What range in between that you actually need your data to be perfectly concise and consistent? You're going to want to think about your messaging system that you use. This is critical plumbing, and we're at a stage in the evolution or the life cycle of messaging solutions where no clear winner has emerged yet, and there's not a lot of interoperability between different approaches to messaging. There's not a standard, there's not a protocol that I'm aware of at least. So do your research, find out what's going to work best for your particular use case, and be very thoughtful about it. So I've talked about hexagonal architecture a bit. I've talked about messages and APIs. These are organizing principles that help us look at the problem of architecture. And there's one other aspect to architecture that I wanted to bring up. We were very fortunate to have Sandy Metz here speaking to us at this conference. And when I read Practical Object-Oriented Design in Ruby, it reminded me of what I liked about OO, and it sort of took me back to when I first learned how to do OO. And I think one of the main messages that I took away from her book, that as developers, we think a lot about objects, but we should think more about messages that are sent between objects. That's really at the heart of what OO is. So I had this revelation. What if we think of an application as an object? Can we apply the principles of object-oriented design to architecture itself? OO is a proven formula for successful, solid design. It's been around with us for quite a while. There may be other trends that are emerging now if you were in the other talk. But we think of classes communicating via messages. We can think that that is the equivalent of applications communicating via messages. Some other OO principles that we can apply. Cohesion. An application is a group of components that perform a function on the same data. We can apply the single responsibility principle to applications. An application should do one well-defined thing. We should use APIs, which are a kind of contract. We can add methods, but not change methods that are already there because we don't want to violate the contract that we have with the rest of the ecosystem. And we can change our underlying implementation without changing the methods that we expose via our APIs, or we can version our APIs. We don't care about which application sends a message or which application processes the message. We just care that the messages are being sent and the correct consumer will be listening to the message that we're sending and take the appropriate action. We can create client-specific interfaces using APIs, and the clients might be other applications. They may be users. They may be a data dump that you want to send to someone. By creating APIs, you'll find that you can re-enable that sort of special feature of OO where you are able to use code in novel ways, ways that you weren't exactly predicting at the beginning when you were doing your initial coding. So how many of you have legacy applications that you're working with? And let me define legacy application for you. It's not an application that is a year old or 6 months old or 2 years old. It's not an application necessarily that's version 2 of Rails. It's an application that you have stopped paying attention to. How many of you have legacy applications? Okay, there's a few more hands up. So age is not measured in chronological time. It's spans of attention. I know that there are things that I worked on 6 months ago that I haven't looked at since then, that if I go back, I don't have them in my head anymore. I don't have a picture of what they're all about in my head anymore. I have to look at my test suite to figure out what were the special edge cases that led me to design in this particular way. There's some things that I think are really important, and I'm writing a book with Kerry Miller about legacy applications, and one of the sort of key things that we agreed on at the beginning was that it's important to think about not only the mechanics of dealing with legacy code, but the attitude with which we approach legacy code. Legacy code is not broken. It is unfamiliar code. It was created under circumstances that you don't understand, or maybe that don't exist anymore. The people who are responsible for legacy code were not stupid. They were working under conditions that you don't know about. They were sincere, they were hardworking, and they were doing their very best. Don't get blamed. No good can come from that. A legacy application contains vital information about your business. There are edge cases that you don't know about that are just sort of magically handled in the background. You want to mine those legacy applications for that information and for that knowledge. Otherwise, you're throwing away person years of thought and problem solving. So it's very tempting to say we want to redo from start, and someone actually brought that up in the refactoring workshop yesterday. But you're throwing a lot away in exchange for the privilege of greenfielding. So how do we actually tackle these legacy applications? Dismantle God classes. You can use Code Climate to find the classes that are the biggest violators and start taking them apart. At my last job, we had a user model that understood over 2,000 messages. And I don't think we were unique. Who has a user model that's less than 100 lines of code? Okay, I didn't think so. I had the privilege of working with Corey Ehmke, and he taught me about modules and how to use modules to contain as a container for behavior. And he named them. I was an English major, so I came up with clever mythological names for all the stuff that I created. And he named things like works with blah, or implements such and such. And he was right, and I was wrong. So you might have a requires permissions module that you include in your controllers, or a works with date ranges module that provides a set of named scopes for several of your modules. And although I would love to call those like Cerberus and Cyclepomp, I won't. So look at engines very carefully. Engines are really, really neat, and I think they're really underutilized. Devise is a great example of an engine. Think about moving models. Like engines let you take an entire MVC stack and make it portable and package it as a gem. So think about taking your models and your business logic and your controllers and views that are about a single thing and moving it into an engine, because once you do that, you can pick those engines up and build an entire application around it. It's a nice way to extract your code and then refactor it into a small standalone application. The observer pattern is really cool. Rails observers are synchronous, which makes no sense to me at all, and to me violates the principle of least surprise. Be explicit about the behaviors that you want to happen when an object changes state, and do it asynchronously using your message bus. I believe that persistence in this day and age should be an asynchronous operation. If you're validating before you're trying to do a write, most of the time your write is going to happen. I would say to 10 nines, your write is going to happen. So deal with the exceptions, but don't say, hey, did you really write to the database? Okay, I can move on. Another area of plumbing you don't want to skip on is your API design. I would even go so far as to say, since we don't have interfaces, you can use your API to refactor your models, your fat models. That user model I talked about with 2,000 messages, we found out when we built our API, we built it piece by piece by piece. There were 12 methods that it needed to expose to the world out of that 2,000. Think about synchronicity versus asynchronicity. One example is you have a client application that needs to authenticate a user. That's a great use of a synchronous call. You send the credentials across, you get the auth token back. It's a fairly lightweight operation. You want to use a message queue for asynchronous calls. So the persistence example I was talking about, maybe the user has updated their preferences, and you can afford to wait 5 seconds for that change to take effect. They change some of their attribute, they correct a misspelling of their company name. You can wait for that change to take effect. So whatever you can do asynchronously for, excuse me, for performance reasons, do it asynchronously. If you have sets of functionality that could potentially serve multiple applications in your ecosystem, extract them into services. I did use the S word, but just this once. Persistence, authentication, authorization, reporting, all of these are great candidates for moving off into applications that expose a layer, expose functionality through an API. I would encourage all of you to explore the presenter pattern. You might be familiar with a tool called Draper. There are other tools that perform similar functions that basically allow you to be really, really explicit about the methods and attributes of your objects that you want to expose to the world and help you hide the internals. I'm a fan of faceted because I wrote it. And yes, all my open source projects have logos. It's a declarative framework for building APIs. So if you've ever used Mongoid, you know how you, instead of having a schema, you say field X, field Y. Faceted lets you do the same thing with your presenters, except those attributes that you declare can be methods in the presenter, like a decorator, for example, or it might be a method on the object that you're calling, or it can be a direct attribute on the object that you're presenting. So we've talked about different refactoring techniques and some of the philosophical approaches to refactoring that you might take, some of the ways that you might attack your legacy application, break it into smaller pieces that are more manageable. What do we get on the other side of refactoring? You might end up with something like this. This is actually very, very similar to the architecture I built at my last job before I came to apartments. We took our legacy application, this awful monolithic thing that was ironically called Diablo, very aptly named, and we made it our persistence API. That's all it did anymore. We slowly stripped out all of we went interface by interface, user group by user group, and stripped it out into small applications. So we ended up with a reporting API, a persistence API, and a messaging API. And everything else in our suite of internal and external applications, including iOS apps and Android apps, used this layer to communicate with the business. So we had our consumer application, we had a few different internal applications. We had a hack day one day, and if you don't do hack days, I really strongly recommend it. We had a hack day. I happened to have built our reporting infrastructure with faceted. I dropped it in just as an example to show someone how easy it was to integrate. So we spent like a couple of hours doing that. And our next hack day, someone came up with the idea. We had a sales team. And salespeople are highly motivated by numbers and by statistics, and they're also very competitive. So someone at the hack day had the idea of what if we built a dashboard for sales that gave them real-time data on how they were selling, broken out by sales team. Wouldn't that be cool? And I was like, you know what? We have an API for that already. So 2 of us, over a period of like 6 hours, most of which was taken up by UI, built this dashboard that now it lives on giant television sets throughout the sales area. And we actually saw an uptick in sales performance as a result of providing them with this information. And it was a great example, I thought, of a client-specific or user-specific interface that was a delighter that was unexpected. It was novel use of infrastructure that we had previously built. So some of the benefits on the other side of this, because this is a very arduous process, and it's going to take you a year at least, depending on the size of your application. You need to think about the positives that you're going to get on the other side of this, and use that as motivation to get through the slog work that you're going to have to do as you break your infrastructure up into smaller and smaller pieces. You are going to end up with a reduced cost of change. According to Sandy Metz, this is the principal virtue of object-oriented design. You're going to have the cost and friction around adding new features greatly reduced. Another thing that was an unexpected side effect for us, we had different teams that were focused on building different small applications. We found that the teams developed a great autonomy. When I started there, we had 2-week sprints, and every 2 weeks we would release. And it was kind of a big deal, and all the engineers, it was everyone on deck. You couldn't work from home on those days. QA was involved. There was always some sort of crisis that would emerge because it's a production deployment and that sort of thing just happens. But as we broke into smaller apps, we found that Team A could deploy on Tuesday afternoon at the height of business. And because messages were stacking up in a queue, the application was ready to process the messages when it came back online. And the rest of the apps in the ecosystem had no idea that for that minute and a half that it took to spin up the Heroku app, that service was unavailable. So all the teams became autonomous and were able to release at will. And we no longer had those bi-weekly releases. Whenever a feature was ready, we shipped it. And that's supposed to be what Agile is all about anyway. So downtime became really, really low impact. Another thing we found is that, as I mentioned before, there are a lot of new devs who are entering our industry. And one of the hardest things for people to do when they're starting at a new company, let alone a new career, is take a complicated system and build a picture of it in their head. And if you don't have that picture of what your system looks like in your head, any contribution you make to it is likely to be wrong or duplicated or something that really should be short-lived, but the longest-lived code is a temporary code. So if you break your architecture up into lots of small applications, these small applications are easy to understand. It's easy to look at an app that handles authorization and understand how it works. And then you can move on to the next piece that is actually its own repo, its own application, and see how that interacts with authentication. And you can slowly build up your picture instead of having to wrap your head around this big monolithic group of functionality. We talked about TDD before and how over time you can't do it anymore. When you have small applications, and especially when you remove persistence from the picture, your test suites run fast again. And you can actually do true TDD, where you change one line of code to change the message of your failure, run your test, see the message, go back and change the message, and repeat until you're happy with the code. Another sort of novel thing that emerges from this sort of architecture is you can do A/B testing on your infrastructure. If you're not familiar in sort of marketing, in the marketing world, A/B testing is where you have a landing page that has a headline at the top on the right in 18-point type, and you have another landing page that has it on the left in 18-point type. Actually, you want to change one thing at a time, and you direct a certain amount of traffic to either landing page and see which one performs better. So you can do multivariate testing where you change lots of things at the same time and you throw them up and see what sticks. And over time you arrive at what is the optimal solution based on actual behavior. With a small app architecture that's message-based, again, we don't care who consumes the message. Multiple applications can consume the same message and do different things with it. So let's say you're thinking about moving to MongoDB, but you've heard that there might be some performance issues with it. Add another persistence layer to your ecosystem. So you have your Postgres listener that's consuming messages that have to do with saving models. You also have your MongoDB listener that is doing the same thing. And you can wire each of them up to your reporting application and see which one performs better. You can direct, if you're not using messages to allow multiple consumers, you can direct X amount of traffic to the API of one application versus the other application. One of the other benefits you get is that you have flexibility in the tools that you bring to bear. You can build an app in Node.js that understands JSON and point it to your JSON API. You can have small applications that are better suited for Sinatra that don't need all of the overhead of Rails. You can build your application in Elixir, and as long as it understands HTTP, it will talk to the other applications in the ecosystem. What this really gives us, it allows us to live up to the ideal that we're sort of hinting at the beginning with ad hoc architecture, which is the democratization of architecture. I believe that architecture is something that, although once it was the province of architects, that job title is sort of on the way out in a lot of respects, especially at smaller, more agile companies. And instead, architecture is something that all of us own, and all of us contribute to, or all of us take something away from. So it behooves us to be the best architects that we can be, because it is a shared responsibility now. That the ideal that we want to accomplish is that all of us are equal participants in a democratic system of architecture that quality will emerge from. So I've taken this approach at several different shops that I've worked at. You can too. Start small, be really thoughtful. If you don't agree with the tactics and strategies that I've outlined, don't follow them, but do something. Don't be a prisoner to your legacy code. I'm Corey Ehmke on Twitter. If you think some of the ideas that I've shared today are interesting, go to smashthemonolith.com and sign up to find out more about the book that Carrie Miller and I are writing on this very topic. I thank you for your time and attention, and I hope that I've been helpful to you in sharing some of the things that I've learned as I've worked with legacy apps. It looks like we have 9 minutes, and I'd like to open it up to questions. Thank you.